Hello everyone, welcome into another lesson. So today we're going to talk about other types of angles inside of a circle. So far we've talked about central angles, then yesterday we talked about inscribed angles. Today we're going to talk about other types of angles. And this will be the last lesson on angles of a circle. The next and final lesson of the circles unit will be about segment lengths inside of circles. So here is our first type of other angle of a circle, where you have a circle here with two chords that intersect inside of a circle. Whenever you have that, this theorem states that the measure of an angle formed by two chords, which you see here, that intersect inside of a circle is equal to half the sum of the measures of the intercepted arcs. So here you have angle 1 formed by two chords that intersect. Well, it intercepts both arcs x and y. In order to find the measure of angle 1, you would take half of the sum of these two arcs. That's all that theorem states, and we're going to do some exercises real quick here to illustrate that point. We will illustrate that point here with a few exercises for this. Then we'll come back. There's another theorem we're going to talk about for other types of angles. All right. I'd like to make this a little bit bigger, I think. I'd like for everyone to be able to plainly see what we're talking about here. Okay. There we go. Perfect. Let's see what else we're given here. Oh, let's see what they give us. In this one, they give us that the measure of arc RT is 80. So the measure of arc RT here is 80 degrees. The measure of arc US is 40 degrees. Okay, so what we need to do now is we need to find the measure of angle 1. So find the measure of angle 1. Well, again, we see that angle 1 is formed by two chords that intersect inside of this circle. It intercepts the arc with 80 degrees and 40 degrees. So to do that, to find the measure of angle 1, you're going to take half the sum of the 80 degree arc and the 40 degree arc. So half of 80 plus 40, which of course would be equal to half of 120 degrees, which then, as we know, half of 120 is 60. So the measure of angle 1 in this case would be 60 degrees, half of the sum of the two intercepted arcs. And then 3 more exercises with this. And then we'll move on to the other stuff. What do they give us this time? They give us that the measure of, different. Arc RU is 130. Then they give us that arc TS is 100 degrees. Alright, so we don't know RT or US, right? But we do know RU and TS. However, what I would recommend temporarily since we're going to first have to solve for this angle here, I would call this angle 2. Ultimately, we want to find angle 1, right? But I would place an angle 2 here since you have the other arcs. Go ahead and solve for angle 2, and then we can deal with angle 1. So let's solve for angle 2. The measure of angle 2 would again be half the sum of these intercepted arcs, which would be half of 130 degrees plus 100 degrees, which means it's going to be equal to half of 230 degrees, which, what is half of 230? It's 115. So there, we got the measure of this angle being 115 degrees, right? We can go ahead and write that in now, since we found the angle. Now, I think it's plain to see that the measure of angle 1 plus 115 would equal 180, right? It would form the straight line TU. So now we can solve for angle 1. So the measure of angle 1 plus 115 degrees is equal to 180 degrees, which would then have to mean that the measure of angle 1 would be equal to 65 degrees. So what you should get in the end, when you figure out this angle and then take angle 1 and 115 set equal to 180, you should get that the measure of angle 1 is 65 degrees. 2 more exercises with this one, then we're going to move on to the other types of angles. Let's eliminate that. All right. Let's refill this in where I kind of decimated that. All right. Let's see what we got next here. In this exercise, this time we have the measure of angle 1 is 50 degrees. So we actually have an angle measure this time. We even have that, TS. I'm sorry, I was looking at the wrong one. Measure of angle 1's 50. RT has a measure of 70 degrees. We need to find the measure of US. So, let me write down what our objective is for this one. Find the measure of arc US. There we go. So what do we know about angles formed by 2 intersecting chords inside of a circle? That they're equal to half the sum of the 2 intersected arcs, right? So what you're going to do in this case is take that angle measure, which is 50 degrees, you're going to set that equal to half the sum of the intersected arcs of, which would be the measure of arc US plus the 70 degrees. Now all you got to do is multiply both sides by 2. You would end up getting that the measure of arc US plus 70 degrees is equal to 100 degrees when you multiply both sides by 2. Which then would simply mean that the measure of arc US would have to equal 30 degrees. So what you should get for the measure of arc US is 30 degrees. One more exercise with this one and then we're good. Then we'll move on to the last theorem, which involves 3 other types of angles. Let's see what we got for the very last one. We are given measure of angle 1 is 52 degrees. So here's 52 degrees. Measure of US is 36 degrees. We need to find the measure of RT this time. So we are going to find the measure of arc RT. All right. So this time, once again, we have the measure of the angle formed by the two intersecting chords. That, of course, is equal to 1/2 of the two intercepted arcs. So take your 52 degrees. I want to write in a different color so you can see it a little bit better. There we go. So take your 52 degrees. You will set that equal to 1/2 of the measure of arc RT, since we don't know that yet, plus the measure of arc US, which is 36 degrees. Now again, multiply both sides by 2, you would end up getting that the measure of arc RT plus 36 degrees would equal 104 degrees. Now you just have a simple subtraction problem. What is 104 minus 36? That's going to be 68. So the measure of arc RT in the end would be 68 degrees. So working with this theorem is really not that bad. It's actually pretty simple. Now let's move on to the next set of other angles for circles. It's a three-parter, so, but I will draw illustrations for all three, of course. All right. Theorem. Alright, I'm going to change the wording for each of the three types, but they're very similar in a lot of ways, but yet different. So, I'll talk about the example here in a second. So here we have a circle, of course. Alright. We will call this angle 1 here, again, in true fashion. We'll call the measure of this arc X, we'll call the measure of this arc Y. Then let me write down the formula here real quick, and I'll explain it. Alright, so this first part of this theorem states that, man, if I quit knocking crap over, okay. The measure of an angle formed by two secants drawn from a point outside a circle is equal to half the difference of the intercepted arcs. So here you have a circle with two secant lines that start from a point outside the circle. To find the measure of that angle 1, that's going to be equal to half of the difference of the two arcs, which would be half of x minus y, you're always going to start with your bigger one. Sometimes it might be y minus x. Either way, it's the difference of the two arcs. You do half the difference of the bigger angle minus the smaller angle. Oh, the arc, rather. You get what I'm saying. So, there's for that. Now let's talk about case 2 of this theorem. Alright, so then we have case 2 where you have a circle with two tangent lines that start from outside the circle. It's the same thing for this part 2 of the theorem. The measure of an angle formed by two tangents drawn from a point outside a circle is equal to half the difference of the intercepted arcs. So again, to find the measure of angle 1, it's going to be equal to half of x minus y. So it would be equal to half of the bigger arc minus the smaller arc. So that's pretty simple too. Same with secants, same with tangents. And then there is one more scenario. There is just one more scenario here. But it's going to be the same thing ultimately. And then you have scenario 3 where you have a circle with an angle outside of the circle that is formed by a secant and a tangent line to the circle. This theorem states that the measure of an angle formed by a secant and a tangent drawn from a point outside the circle is half the difference of the intercepted arcs. So angle 1 would be equal to half of x minus y, or half the bigger arc minus the smaller arc. So for all three scenarios there, it's the same, whether it's two secants, two tangents, or a secant and a tangent. It's half the difference of the two arcs. And we got some exercises with that. So let's do that. Now, what the hey? There we go. Let's see what we have here, okay? Okay, let's see what they give us here. So we obviously are going to need to find the angle formed by a secant and a tangent line. They give us that the measure of arc CT is 110 degrees. In this case, there's three exercises for this actually. BT has a measure of 50 degrees. So we need to find the measure of angle A, which should be pretty simple. We're going to find the measure of angle A, which of course is formed by a secant and a tangent line. Well, to find the measure of angle A, that's going to be equal to half the difference of the intercepted arcs, which the bigger arc is 110 degrees, then minus the smaller arc, which is 50 degrees, which would ultimately end up being half of 60 degrees, which could only mean then that the measure of angle A would be 30 degrees. So when you apply the formula for an angle formed by a secant and a tangent line, the measure of angle A would be 30 degrees. Two more exercises with this one, and then we got a few more other angles, and then we're going to do a grand finale exercise for all the angles we've learned so far. So what do we got next here? Measure of angle A is equal to 28 degrees. This time this has an angle measure. Let's see, measure of angle BT, measure of arc BT is 46 degrees. We need to find CT. We need to find arc CT. So find the measure of arc CT. Okay. Again, we know that the measure of an angle formed by a secant and a tangent line is half the difference of the two arcs, right? So we already got the angle measure. In this case, that's going to be 28 degrees. That's going to be equal to half the difference of the two arcs, which would be the measure of arc CT minus the measure of arc BT, which would be 46 degrees. Now you just multiply both sides by 2. You would end up getting that the measure of arc CT minus 46 degrees would equal 56 degrees. Which then we can finally solve for the measure of arc CT. So 56 plus 46 would be 102. So the measure of arc CT that you should get would end up being 102 degrees when we apply the formula. And there's one more exercise for this type. Alright, so what's next here? In the last problem of this, we have the measure of angle A is equal to 35 degrees. We have the measure of CT is 110 degrees. We need to find BT. So we are going to find the measure of arc BT. Okay, so once again, what we do know is that we have the angle this time formed by the secant and tangent line. That, of course, is equal to half the difference of the two arcs. So take your 35 degrees, set that equal to half the difference of, in this case, I'm going to do the 110 degrees minus the measure of arc BT. There's a reason for it. I mean, I suppose it doesn't matter what order it's in, but you probably don't want to deal with negative numbers if you can help it. If we did it in reverse, we'd be dealing with negative numbers. Okay, so go ahead now, multiply both sides by 2. You would end up getting 110 degrees minus the measure of arc BT would be equal to 70 degrees. Which, if you simplify this, you would just end up getting that the measure of arc BT would be equal to 40 degrees. So, the measure of arc BT in this case is equal to 40 degrees. So, really not that bad. Alright, now I got 5 exercises here with another type. Good news is we've learned all the theorems for today, so let's move this over some. There's a reason I'm saying that. Alright, what do we got here? Alright, so we're going to have, again, a circle, but this time with 2 tangent lines to the circle. We get, in this case, that the measure of arc XYZ, which is the major arc, is 250 degrees. We get that the measure of the minor arc, well, we just need to find angle P, but of course, in order to find the minor arc, we just take 360 minus the major arc, right? What is 360 minus 250? It's 110. So you'd end up getting then that XY, minor arc XY is 110. Now we can solve for angle P. So to solve for angle P, once again, that's going to be equal to half the difference of the 2 arcs, so it would be half of 250 minus 110, which would end up being half of 140 degrees, which means that the measure of angle P would be 70 degrees. So, using the same rules here, that the measure of an angle formed by 2 tangents from outside a circle is equal to half the difference of the 2 intercepted arcs, you get that the measure of angle P equals 70 degrees. Alright, what do we got next? This time they give us that the measure of minor arc XY is equal to 90 degrees. We need to find the measure of angle P, but in order to find the major arc XYZ, you just take 360 minus 90. That would give you 270. So the major arc XYZ is 270. Now we can easily go through and find the measure of angle P. So let's go ahead and do just that. The measure of angle P, once again, is equal to half the difference. This case would be of 270 degrees minus the 90 degrees, which 270 minus 90, that's 180, so that'd be half of 180 degrees. Half of 180 is 90. So the measure of angle P in this case would equal 90 degrees. Alright, 3 more exercises with this and then we'll go on to the grand finale for the angles. It's going to combine all the angles of circles we've looked at so far in this course. Actually all of them, because this is the last lesson on angles of a circle. Number 3. Okay. I'm sorry, there were only 4. There were only 4. It looked like 5. There were only 4, so we got 2 more. The measure of arc xy is equal to t, so this is a bit of an algebraic one. Okay, we need to find the measure. So this is a two-parter. Find the measure of major arc xyz and the measure of angle P. So what do we know about finding the major arc? It's 360 degrees minus the minor arc, right? Well, if you just have t for your minor arc, all that the major arc is going to be is 360 minus t. That's the best we can do for it. It's 360 minus t, unfortunately. So that means we have a measure of major arc xyz, which would simply be equal to 360 minus t. That's the best we can do for that one. Now the other facet to this is finding the measure of angle P, which isn't too bad to find either. If we remember, the measure of the angle formed by two tangent lines outside a circle is equal to half the difference of the two angles. So that's going to be half of 360 minus t, which would be another minus t, which would then have to mean that the measure of angle P equals half of 360 minus 2t, which if you distribute that half, you would end up getting that the measure of angle P equals 180 minus t. So in terms of t, the measure of angle P is equal to 180 minus t. So that was a bit of an algebraic one. Alright, one more exercise with this and then we'll go on to the grand finale for the angles of a circle. Alright, what do we get this time? Measure of angle P is 65, so we're actually given an angle measure for that angle. Alright, so we need to find the measure of arc xy. Well, this is going to be a bit of a doozy because we're going to have to figure out these missing arcs. So what we're going to have to do is we know that ultimately the angle formed by two tangents is what? Let me state what we're trying to find. The measure of arc xy is what we're trying to find. But anyway, the measure of the angle formed by two tangents, in this case 65 degrees, is going to be equal to half the measure of major arc xyz minus the measure of minor arc XY. And this actually isn't as bad as you think. We have, of course, arc XY. However, we need to account for XYZ in terms of arc XY. Well, what would arc XYZ be in terms of XY? That's actually quite easy. You just take 360 minus the measure of arc XY and you got it. It's going to be equal to 360 minus the measure of arc XY. That would be the measure of arc XYZ. So now this is where it gets fun. So then you're going to have 65 degrees is equal to half. Let's substitute that value in for the measure of arc XY. That'd be half of 360 degrees minus the measure of arc XY minus the measure of arc XY. So you see where we're going with this? Now let's see here. Let's simplify this a little further. You would get 65 degrees equals, we'll still keep the half for a minute, half of 360 degrees minus 2 times the measure of arc XY. And believe it or not, we are close to done with this. Distribute your half on the right hand side, you'll end up getting that 180 degrees minus the measure of arc XY is equal to 65. And now we can simplify this and find the measure of arc XY. The measure of arc XY would be equal to 115 degrees. So that one took a little bit of figuring out. You had to get the measure of the major arc in terms of minor arc XY, which would be 360 minus the measure of arc XY. When you do that, you end up getting the measure of minor arc XY is 115 degrees. All right. Time for the grand finale here. For the angles. Draw this nice and big. It's going to look intimidating, but it's really not that bad, I promise. Okay. Have, of course, center O. And then alright, I think we formed everything. Now we just need to label more points. This would be point E. This would be here, point D. We got point C, D, E, O, B, Z, A. Alright. And I'm still not done yet. This would be angle 1. This would be angle 8. This is angle 3. Here's angle 9. Here's angle 10. 4 and 5. Here's angle 4 and 5. Angle 6, angle 2, and angle 7. All right. So we just need to find 10 angles here. We need to find 10 angles. What do they give us? They give us that AC is the diameter. The measure of arc BC is 90 degrees. They give us that, which is going to help here tremendously. The measure of CD is equal to 30 degrees. Then the measure of DE is equal to 20 degrees. We need to find all the other angles. So we can definitely start with angle 1. You see angle 1 is a central angle, right? It intercepts arc BC, which is 90 degrees. Well, we know that a central angle is exactly equal to the measure of the arc it intercepts. So the measure of angle 1 easily is going to be 90 degrees. We have solved for that. In fact, as we solve these, why don't we fill these in? It's going to help us. So the measure of angle 1 is 90 degrees. We've solved for that. So what else do we have here? Let's look at angle 2. Angle 2 is an angle inscribed in a semicircle. What do we know about an angle inscribed in a semicircle? That it's a right angle. So angle 2 would also be a 90-degree angle because it is an angle inscribed in a semicircle. So we'll go ahead, we'll label that one being 90 so we know which angles we found already. Now, let's look at angle 3. What is angle 3? So, angle 3 is an inscribed angle. It intercepts both arcs CD and DE, right? Well, CD is 30 degrees, and then DE is 50 degrees, right? To find the measure of angle 3, what do we know about an intercepted angle? What do we know about an inscribed angle? It's equal to half the measure of the arc it intercepts, which in this case would be equal to half of the measure of CD, which is 30, plus the DE, which is 20, because it actually intercepts both arcs, which means it's equal to half of 50 degrees, which could only mean then that the measure of angle 3 is equal to 25 degrees, since it's equal to half the measure of the arc it intercepts, since it's an inscribed angle. So now we have that the measure of angle 3 is 25 degrees. Well, okay, now let's go ahead here and look at angle 4. We have yet another inscribed angle. It intercepts arc AE. Well, I think first it would be wise to solve for arc AE. We know it's inside of a semicircle, right? Arc AE is, well, arc AC is equal to 180. It's equal to the sum of arcs CD, DE, and AE. Well, CD and DE together equals 50. So if you take 50 and subtract that from 180, you would get that arc AE equals 130 degrees. So now we just solve for the missing arc, AE being 130. What do we know about an inscribed angle? It's equal to half the measure of the arc it intercepts. So the measure of angle 4 is equal to half of 130 degrees, which means what? That the measure of angle 4 is going to be equal to 65 degrees. So we can now fill that in since we know that information. All right, let's look at angle 5. This is an angle formed by the intersection of two chords. What do we know about an angle formed by the intersection of two chords? It's equal to half the sum of the two arcs it intercepts. So if we look at the chords that form angle 5, EC and then DB, it would definitely intersect the 90-degree angle, the 90-degree arc, and the 20-degree arc. So the measure of angle 5 is going to be equal to half the sum of the 90-degree arc plus the 20-degree arc, which would mean it's equal to half of 110 degrees, which could only then mean that the measure of angle 5 would have to equal, what's half of 110? It's 55 degrees. So we got the measure of angle 5 now being 55 degrees. Okay, I think we're going to go ahead and erase some of these since we're halfway done because we're running out of room and we still have 5 more angles to find. But this is actually a nice little puzzle to solve for. Start from scratch, find a bunch of angles. So if everyone got this, I'm going to go ahead and erase these now so we can find the other 5 angles because those are going to require some work too. What do we have now? Angle 6. Okay. Here's the thing about angle 6. It's formed by chords. It's the intersection of chords DB as well as CE. Alright, so let's take a look at this here. Yeah, it's BD and CE, which would definitely, this angle here, because vertical angles are congruent, would be intercepted, of course, by intercept the 30-degree angle. But then the other part of that is, what is the arc that it intercepts? Let's take a look at this here. It goes from here to here. So that would be this arc right here. it's actually going to be all of this. It's going to be the 130 plus this portion to find the measure of angle 6. It's the 130 plus this portion. So I think it's actually important first to find this missing angle here so we can get a measure of arc AB. Well, if this is 90 degrees, this also has to be 90 degrees. That means the measure of arc AB would actually also have to be 90 degrees. So, in order to find the measure of angle 6, which is what we want to find, since it's an angle formed by two chords intersecting, that's going to be equal to half of the arcs it intercepts, which would be the 90 plus the 130, so that'd be half of 220, plus then, of course, the 30-degree arc, which it also intercepts, which would have to mean it's equal to half of 250 degrees. So then that means the measure of angle 6 would be equal to 125 degrees. So yes, the measure of angle 6 is equal to 125 degrees. Alright, so let's go for angle 7. Angle 7 is an angle formed by two secant lines outside of the circle. It clearly intercepts the 90-degree arc and the 20-degree arc. For an angle formed by two secant lines outside of the circle, it's the difference of the two arcs. So the measure of angle 7 would be equal to half of that 90-degree angle, and that 90-degree arc, minus that 20-degree arc, which means it's going to be equal to half of 70 degrees. Well, what is half of 70? It's 35. So the measure of angle 7 in this case would be equal to 35 degrees. So now we can go ahead and fill in the measure of angle 7 as having a 35-degree angle. Alright, so now we just got to figure out angles 8, 9, and 10. Alright, so this chord here, this angle here is an angle inside of the circle with two intersecting chords, which are going to be formed by, of course, it's going to be the half the sum of chords CD and AB, because that's what it intercepts. So the measure of angle 8 is going to be equal to half the sum, since it's an angle formed by two intersecting chords inside the circle, of the 90 degrees plus the 30 degrees, which would mean it's half of 120. Well, what is half of 120? That's 60. So the measure of angle 8 would equal 60 degrees. Just two more angles to find. Alright, so now we just got to find angles 9 and 10. That should be fairly straightforward, actually. What do we know? Angles 9 and 10 are going to be the same. I'll tell you why. Because both arcs that they intercept are 90 degrees. We know if we have an angle formed by a tangent line and a chord on the circle, by a tangent and a chord, that it's equal to half the measure of the arc it intercepts. So the measure of angle 9, in this case, let me erase this one here since we've already done 6. the measure of angle 9 would be equal to half of the 90-degree arc that it intercepts. Since it's formed by a tangent and a chord, it's equal to half of the measure of the arc it intercepts. So the measure of angle 9 would be equal to 45 degrees. And then, of course, we have the measure of angle 10. It's going to be the same deal. Measure of angle 10 is also equal to half of 90 degrees, which means the measure of angle 10 is equal to 45 degrees. So yeah, that was a good grand review of all the angles we've had so far. That was a very good review. So this whole angle is 45 degrees. So now we found all 10 of our angles. And that's it for angles of a circle. The next lesson will be the final lesson of circles. I know most of you are probably relieved on that. We're going to talk about segment lengths and circles. So I hope everyone has a great day. Take care.